Hello everyone. Before starting the lesson, try the warm-up. Write the recursive formula and the explicit formula for each sequence. So there are two different sequences. See if you can write the recursive formula and the explicit formula for each. You might have to refer to your notes from the previous lesson, but that's fine. Pause the video and try this on your own. The first sequence is an arithmetic sequence because I have a common difference between each term in the sequence. So to find out the term value, you take the previous term and add 4. That's what is happening here. So that's the recursive formula. To find the term value, it's the previous value plus 4. But if I want the explicit formula, I'm starting with 5 and I'm adding 4 n minus 1 times. So Tn, the term value, is equal to 5 plus n minus 1 times 4. That would be the explicit formula. The other sequence is a geometric sequence because from one term to the next, I'm multiplying by -3 every time. So there's a common ratio between successive terms. So to find a term value, I'm multiplying the previous term by -3. This is the recursive formula. The explicit formula, to find the term value, it's 5 multiplied by -3 n minus 1 times. So the exponent is n minus 1 there. This was a recap from the previous lesson. If you need help with that, you should get that help before you move on to the next lesson. In this lesson, we talk about series. So we're going to determine the sum of the terms in a sequence, because that's what a series is. A series is the indicated sum of the terms in a sequence. So some notation, S with a subscript of 2, or S2, means the sum of the first 2 terms in the sequence. S3 would be the sum of the first 3 terms, etc. Sn would be the sum of the first n terms in general. So whatever the subscript number is, that tells you what term you're adding up to. So here's an example. This is called an arithmetic series because there's a common difference between all the successive terms. I'm adding 2 to get to the next term in the sequence, but it's a series because I'm adding up each term as I go. Notice the addition symbols in between the terms in the sequence. So if you're adding up the terms, this is a series, and it's arithmetic because I have a common difference between the terms. So as an example, S subscript 3 would be the sum of the first 3 terms in the sequence. 6 plus 8 plus 10, the first term plus the second term plus the third term. So I would say the sum of the first 3 numbers in the series is 24. And here's an example of a geometric series. It's geometric because I have a common ratio between the terms. Multiply by 2 every time. That makes it geometric. And it's a series because I'm adding up the terms as I go. I'm getting the sum of the terms in a geometric sequence. So again, if I wanted the sum of the first 3 terms, I would just add up the first term, the second term, and the third term. And I would get 42 as my answer. So this is just to show you what the notation means. Now here's an example of an arithmetic series. The same one I showed, 6 plus 8 plus 10 plus 12 plus 14, etc. It's sometimes tedious to just add up each term as you go. For example, if I wanted to find the sum of the first 100 terms in this series, that would be a lot of addition in your calculator. So I can use a formula to speed things up. This formula, I won't show you how it's derived. It's a little beyond the scope of this course, but if you use this formula, you can find the sum of the first n terms. For example, if I wanted to find the sum of the first 3 terms, using this formula, it would look like this. N is the term number, 3. A is the first term in the sequence, 6. Tn is the value of the nth term. So if I want to find the sum of the first three terms, I need to know the value of the third term. 1, 2, 3, 10 is the third term. That goes here. All of that divided by 2. So just follow BEDMAS, brackets first, then multiply and divide, you get 24. And that's the same sum I got when I just did 6 plus 8 plus 10. I'm just showing you that you can use this formula and you will get the sum of the first n terms. Now I also want to remind you of this formula here to find the general term of an arithmetic sequence. We used this, t sub n is equal to a plus n minus 1 times d. So here's something that's useful. Let's say I wanted to find the sum of the first 100 terms in this series. Well, I don't know what the 100th value is, and I don't want to spend the time to figure it out. I don't know what Tn is, but I know that Tn is equal to this. So I can take this and put it here. Then in these brackets, I'll have a plus n minus 1d. A plus a, well, that would be 2a. So I can write the same formula this way. Now I don't need to know what the value of the nth term is. I just need to know the term number. So if I wanted to find the sum of the first 100 terms in this series, I wouldn't need to know what the 100th term is. But I know that n is 100, and I know the first number in the sequence, and I know the common difference. So I can still find the sum of the first 100 terms in the series. Now I can use this formula to find the sum of the first three terms just like I did here, but I just want to show you that we do end up getting the same answer. The sum of the first three terms, so n is 3. Wherever I see an n, I replace it with a 3. A is the first term in the series, it's 6. D is the common difference, it was 2. And divide all that by 2. And follow BEDMAS. You end up with the same thing. 3 times 16 divided by 2 is 24. So the sum of the first three terms, using this formula, it's still 24. So if you know the value of the term, you can use this formula. If you don't know the value of the term, you can use this formula. Both of them will find you the sum of the first n terms in an arithmetic series. So here's an example. First part, determine the sum of the first 100 natural numbers. As a reminder, the natural numbers are the numbers 1, 2, 3, 4, etc. Just whole numbers, not including 0. Okay, so if you want to find the sum of the first 100, you know that your final term is going to be 100, so you can use this formula. In part B, determine the sum of the first 25 terms in this series. I'm not showing you all 25 terms, but you have enough information from the first three terms that you can use this formula to figure out the sum of the first 25 terms. Pause the video and try both of these questions on your own. For the first one, we're trying to find S100, the sum of the first 100 terms. So n is 100. A is the first term in the series, 1. Tn is the value of the 100th term. The 100th term is 100. All of that divided by 2, follow BEDMAS, we get 5,050 is the sum of the first 100 natural numbers. Second example, we're finding the sum of the first 25 terms. So n is 25. A is the first term in the series, 6. D is the common difference. We're changing by 4. All of that divided by 2. Follow BEDMAS. You end up with 1,350 as the sum of the first 25 terms in this series. If you had issues with that, or you are stuck and you need help, just reach out before you move on to the next question. Now we can do the same thing for geometric series. Here's a geometric series. That's the same one I used earlier in the lesson. I can find the sum of the first n terms in a geometric series using this formula. A is the first term in the series, r is the common ratio, n is the term number. So let's say, for example, I wanted to find the sum of the first three terms in this series. Well, I could do 6 plus 12 plus 24, but I'll use this formula and show you that we get the same thing. So A is 6, R is the common ratio, it's 2 because we multiply each term by 2. N is the term number. I want to find the sum of the first three terms, so N is 3. And I plug in my numbers, follow BEDMAS, and I end up with 42. And that's the same thing I would have gotten if I just did 6 plus 12 plus 24. So just wanted to show you this formula works for a geometric series. So now, your turn. Here's the formula again on the screen. Part A, determine the sum of the first 11 terms in the series, this series. Next one, see if you can do this one. Determine the sum of the first 10 terms in the series. Ooh, we've got some fractions in there. Use the same formula though. So just pause the video and try each of these questions on your own. All right, here's the first one. We're finding the sum of the first 11 terms, so n is 11. The first term in the series is 7, and the common ratio is 3. Follow BEDMAS, you end up with 620,011 as the sum of the first 11 terms in that series. Follow the same method for the second one. We see that the common ratio is a half. We're multiplying by a half every time. We're starting with 5, and we're looking for the sum of the first 10 terms, so n is 10. Now the math might be more difficult if you don't like fractions, but we're just following BEDMAS. Exponent first. 1 to the exponent 10 is 1. 2 to the exponent 10 is 1024. Inside the brackets, this fraction minus 1, so you'll need a common denominator. 1 is 1024 over 1024. 1 minus 1024 is negative 1023 over 1024. If we're dividing by a fraction, it's multiplying by the reciprocal. And then I can just do the multiplication and put it in lowest terms, and this is my answer. It's not a nice fraction, but this is the sum of the first 10 terms in this series. In this example, we're going to use the same formulas. It's just that we're going to solve a little bit differently. Determine the sum of the series. Well, here's the first series we're going to look at. I know that I'm starting with 3, goes to 8, then 13, so I can see the common difference here is 5. But I don't know how many terms there are until I get to this final one of 58. So if I want to find the sum of all of these terms in this series, I have to first figure out which term this is. So I can use this formula to find what n is. I know the term value is 58 here, but what term that is, I still don't know. I know I'm starting with 3, so A is 3. I know the common difference is 5, so D is 5. I still don't know what the term number is, but I have an equation that I can solve. So I'm going to subtract 3 from both sides, then divide by 5, and then I have to add 1 to isolate n. So I end up with 12. N is 12. This is the 12th term in the series. So I'm going to use this formula. I want to find the sum of the first 12 terms, so n is 12. I also know the value of my 12th term, so I can just plug it in right here. I'm starting with 3, follow BEDMAS. 366 is the sum of this entire series. Now you can follow the same method for this next one, but just watch out, this is not an arithmetic series. This is a geometric series. However, you can still figure out what n is first and then find the sum of those first n terms. So pause the video and try this one on your own. Because this is a geometric series, I'm going to use this formula to solve for n. The value of my nth term is negative 49,152. I'm starting with 6. R is the common ratio, negative 2. So if I want to solve this, I can start by dividing both sides by 6. That ends up with this. And if you remember from our exponential functions unit, we just solved for the exponent by guess and check. So this exponent must be 13, but the exponent is n minus 1. So n minus 1 equals 13, which means n must be 14. So now we know that this is the 14th term in the series, so we can find the sum of the first 14 terms. So the formula for the sum of the first n terms in a geometric series is this. A is the starting term, 6. R is the common ratio, negative 2. And n, I established, was 14. Follow BEDMAS, you get negative 32,766 as the sum of these terms in this series. So, big takeaway from this example is that you can figure out what n is if you know what the starting term is, what the common difference or common ratio is, and what your final term in the series is. Then you can figure out what n is. Once you know what n is, you can figure out the sum of those first n terms. Now, my final example is more of a practical one. Brian took a 10-week summer job. The first week he got paid $200. His pay increased 10% per week. Stop right there and think, is this going to be an arithmetic sequence or geometric? What will be his total earnings from that summer job? It's asking for the total earnings. That's the sum of his earnings from each week. So this is a series. But you have to think, is this an arithmetic series or geometric? And then you can figure out the answer to this question. So pause the video and try this one on your own and then check back in to see how you did. To start off with, I'm going to focus on this. His pay increased 10% per week. If your pay increases, you're multiplying by 1.10, and that's happening every week. So this is a geometric sequence. He's starting by getting paid $200 in the first week. That's term number 1. Each successive term is multiplied by 1.10. So we know A, we know R, we know N, because it's going to be the sum of the first 10 terms in the sequence. So n is 10. So as a geometric series, I'll use this formula to find the sum of the first 10 terms. I'm starting with a term value of 200. N is 10. The common ratio is 1.10. Follow BEDMAS, you end up with this number. So I can conclude his total earnings are $3,187.48. So in this lesson, we looked at what a series is. A series is a sum of the first n terms of a sequence. If it's geometric or if it's arithmetic, you have different formulas, but either way, you can plug in your numbers and you can find the sum of however many terms in any sequence. As you're practicing, if you have questions, please reach out for help, and I'll do my best to help you.